Hi, good morning. Today we are going to discuss about digital principles and computer organization. In previous video, we have discussed about the number systems under the unit minimization techniques and logic gates. Now we are going to see about an Boolean postulates and laws, De Morgan's theorems and principles of duality. These are the topics that we are going to cover in this video. Now, let's see about Boolean algebra and theorems. Boolean algebra is an algebraic structure defined on a set of two elements b equal to 0, 1 together with two binary operators either plus or and. Postulates are basic axioms of algebraic structure and need no proof. Closure is a set. The set is closure means the set is closed with respect to the operator plus and dot since the result of each operation is either 0 or 1. First law is we are going to say is identity law. Here we have a is multiplied with 1. We are getting a variable a. A variable and with 1 is always equal to the variable. A or variable odd with a 0 is always equal to the variable. Next one is annulment law. Here a variable and with 0 is always equal to 0 and a variable odd with 1 is always equal to 1. Then independent law. Here a variable odd with itself is always equal to the variable. For example, a plus a equal to a. And a variable hundred with itself is always equal to the variable. A dot a is also equal to a. Then complement law. Here a variable hundred with its complement is always equal to 0. For example, for a dot a complement is equal to 0. And variable odd with its complement is always equal to 1. A plus a complement is equal to always equal to 1. If an variable or with any other variable, a variable with the same variable complement is always equal to 1. At the same time, a variable under with the same complement of the same variable is always equal to 0. In commutative law, here the order in which two variables are under makes no difference. The order of commutative law mainly explains about the order of these variables. If it's equal to if a dot b or b dot a is both are same. Here a dot b equal to b dot a. At the same time, if it is the odd with these variables, there is no difference also. For example, for a plus b equal to b plus b that gives the same values for commutative law that will give the same value. The order in which two variables are odd make no difference. This is the how the switch will act for commutative law. If A and B, A odd with B or B odd with A are will be the same. For example, first diagram we are having A ANDed with B, A dot B, then B dot A. Both are same. We are having a same result of C. And here second diagram we are A ORed with B. We are getting the value of C. B ORed with A. We are getting the value of C. In both the cases, they are having the same value. So A plus B or A or B or B or A is given the same values. Associative law allows the removal of brackets from the expression. For example, a plus b plus c, b plus c comes in bracket, a plus a is added with the a variable is added with the b plus c. In that case, we are having a same value of a plus b plus c. A plus b is bracketed, then we have a variable with c is equal to a plus b plus c. Without bracket, these three have the same values and the same output. This is an associative law. At this, for similarly, we are having under operations. We are having the same result like a bracket b dot c equal to a dot b bracket c equal to a dot b dot c. These are having the same values and the same result. This is called an associative law. For example, we are having an associative law, A plus ORed with B plus C. The value will be A plus B plus C. At the same time, where A ANDed with B dot C, A ANDed with B, then the ANDed with C. Both are having the similar values. This is the associative law. A distributive law permits the multiplying of factors of the variable. For example, A multiplied with B plus C equal to, we are having A dot B plus A dot C. This is how the distribution of variables occurs. The name itself so how distribution take place. Others for AND operation we have explained in AND operation. Now for our operation is same. A plus B dot C equal to A plus B dot A plus C and distributive law. Previously we have seen on or distributive law. Here and distributive law we have approached. This is explained. This is the diagram for a distributive law. First A ordered with B, then ANDed with A ordered C. This is the output. How we are getting the result will be the same. Then double negation law, inversion of a term twice with the result is same term. For example, we are having a double complement for a variable. We are getting the value of original value of that variable. A double complement of a variable is always equal to the variable. Then we are going to see De Morgan's law. De Morgan's law works depending on the concept of duality. It helps in solving the algebraic problems in digital electronics, like A dot B whole complement equal to A complement plus B complement. The negation of a conjunction is the disjunction of the negations, which means that the complement of the product of two variables is equal to the sum of the complements of the individual variable. Is then A plus B whole complement equal to A complement dot B complement. The negation of disjunction is the conjunction of the negations, which means that the complement of the sum of two variables is equal to the product of the complement of each variable. And then duality law, we are going to see how to apply the duality principle. Ones and zeros are interchanged, then undone or operators are interchanged, variables are left unchanged. Dual theorem is still true. Here we are using 1 and zeros are interchanged. That is no changes in variables, but zeros and ones are interchanged, and or operations are interchanged. Here we are going to revise these, what is state De Morgan's theorems, what is meant by duality theorem, how state a commutative law. These are these are the questions that we have to access through these PPTs. Thank you.